This is made in India. Made in India. Eastern technology is in Ahmedabad. Technology was developed by and then transferred there, and then we are the buyers and users. And we supply 50 per year.
You go up to 1000 meters and you tell that today you go to Air Bengal, Vizag you deploy, go to Myanmar and come back. Like that, if you program, it will go and come back. And we communicate to that. So when it goes to diving, it will go perpendicularly like this. When it is gliding like this, it will go. Then it will go and do all this.
Up to 1000 meters it can go, sir.
What are the things it will observe?
Temperature, salinity,
DO, dissolved oxygen, chlorophyll, light.
How much light penetrates into water.
You can also put acoustic sensors.
Anything you
can change the size way. You can put any sensor that you want, but mostly these things it will measure. Acoustics also you can measure.
So we have planned maybe in 1 or 2 years. We go to every year we are going to Antarctica. We deploy one glider, get back in Chennai or Vizag.
And sir, this is part of our deep ocean mission which INCOIS is implementing, sir. So we have 10 such gliders. They are making transects across the equator.
Ready for deploy. So they drag it and just push it.
What is the weight?
80 kg.
80 kg.
And mostly it is all battery, sir. Now they have extended battery pack which can take up to drifting buoy actually. And these are very new measurements, sir. In India, this is the only facility which can calibrate these gliders, deploy these gliders.
So you take off this tire?
Yeah. So this is only pulleys. This is trolley. Just to make it take it carefully.
Where it is available?
Yeah, it is in our lab. In our main lab. We'll show you, sir. Right now, sir. Thank you, sir.
This is what database. This is a radiation. This is a radiation. And this is a air temperature and humidity. And that is also a radiation. So all these parameters will measure. It will be on board ship. So these are all measurements.
35 ships.
So ship it will be kept in this location.
Very difficult to, very valuable information, sir, because otherwise you have to put a mooring to get these measurements. So when you put it on ships.
Yeah, this one.
Maximum.
Yes.
Because the numbers
This is also
give you both the facts.
Correct, sir. Correct. Yeah.
This is a vertical microstructure, sir. This is basically small. Suppose if you put in the ocean this much heat, this much salt, if you put it, how it is mixing, how much time it is taking. So very fine measurement. It is.
This one.
Put this.
Short inside.
This full we have to deploy
it in the water through a rope, like a rope-like measurement.
You have to get it.
In the rope,
It's connected.
And this is a cargo flow. So this particular things will go up and down. This will not glide it.
Okay.
But if this wherever you deploy, it will go this one. It will go down, and it will drift for 10 days in the 1000 meter. And before coming to the surface, it will go dive up to 2000 meter. Then it will, while coming, it will measure all.
So this will go up to
2000
meters,
yes.
2 kilometers.
Yes. 2 kilometers.
That one is
1000
1,000
meters. Yes. And it will give the temperature and salinity profiles and other thing. And over the period, you can see like this.
And this is expendable, sir. Once it is deployed, it will work for
This
150
is 5 years.
And that can
deployed,
be
use and
piloted.
throw.
You can get it.
Use and throw, 5 years it will work. This is the continuing.
This is from Russia.
Yeah.
This is the earlier one. Now we got our own Indian companies making this.
So this will go up to 15 meters. So it is a drop. Right?
You find this
the pressure and temperature of the ocean and along with the currents. This is a
Radiation.
So balloon they launch as IMD. So this will be launched from ship. They launch it, and this is for reception.
This is the sun.
This will be lifted.
This is the only
This is
way.
attached to the bill.
It will go up to 35 kilometers
Okay.
along with the balloon.
Wow.
While going up, it will receive the data from this.
So it's like cargo float in the water. This is in the atmosphere.
So in your profile you can get.
These are hyperspectral radiometers. This is actually like you have seen the satellite today. So similarly, we have a satellite called OceanSat that has actually now 13 bands. That means a camera which can measure in 13 bands. So once we measure what is the reflectance coming out of the sea in different 13 bands, then we can know what is the amount of chlorophyll, what is the amount of suspended sediments, what is the amount of color dissolved organic matter. But
basically, satellite, whatever we are measuring, how do you validate? So this is the instrument to validate and quantify the calibration and validation we can do from.
same camera, what bands are observing there, this instrument can observe in the water. Then we bring the water samples, make measurements, and then we can make those answers. Inherent optical power, scattering, back
Various
scattering.
optical parameters to measure, but this is measure the temperature up to 500 meters. Sorry, how much? 1000 meters.
Yeah.
1000 meters. The thing ship is not required to stop. Here we have to stop it, the CTV, but here no need to stop it. Without stopping, this pull it will automatically record. So that is the way.
Yeah. So these water samples when we bring here, the optical observations, satellite observations we are making, the water samples have to be analyzed for pigments, different pigments, chlorophyll, suspended sediment, all those things are come here. Ocean chemistry lab. This is actually a very advanced equipment, sir. Anish, you can explain. IRMS is?
This is an IRMS. So basically it will tell you how much carbon is taken up by the phytoplankton. So we use it to study the primary productivity. So mainly the primary productivity requires like how much carbon is taken up. It also depends on oxygen and nutrients. So this will give the carbon uptake. So this is a continuous flow nutrient analyzer. So this is also a new state-of-art equipment. So it can give all 5 nutrients together
What are
at
the
the same time.
nutrient contents available in the ocean for fish?
Samples here.
And then the process is going on.
Yeah, actually it is running.
Yeah, it is running.
Right now it is running.
Water samples are going different places.
Hundreds of samples automatically we can analyze, sir, with this equipment. Yeah.
So you can put the 200 samples and then it will run
It
automatically.
will automatically.
It has a gold electrode. You keep the samples, put them and set up the features. And then automatically tell you how much oxygen is there dissolved in the water.
See, ocean oxygen, how much is there, carbon, how much is there, phytoplankton, how much is there, nutrient, how much is there, all these things which is, we will take the sample, bring, and we will. Yes.
This is zooplankton, no?
Yeah.
So, first, whatever,
No, actually it is projected on his camera.
no need to see, we can see here.
Yeah, you can take photograph and sir, that chlorophyll, what we are saying, that is a plant matter in the water. That is actually consumed by zooplankton, and fish consumes zooplankton. So that food chain, how it is building actually based on satellite, we see phytoplankton. We take water samples, we collect nutrients, we analyze them, and then see how much of it will be converted to zooplankton, and then how much can be converted to fish. So all those modeling can be done, but these are the basic parameters we need to estimate.
This is a high performance liquid chromatography, so it will tell you what are the pigments present within the phytoplankton. Like we know chlorophyll is a major pigment, but apart from that there are other pigments, so it will give all And one more thing, we have this incubation box, so whatever productivity we are estimating, we can actually simulate the natural condition in a controlled laboratory. So we do the laboratory experiments and then we get those coefficients.
Sir, simple terms, actually, if you go to the ocean depth, light will become zero. But on the top, photosynthesis will be more. So at different depths, how is it actually photosynthesis is there? That instead of taking a ship and being there for 24 hours, we can bring the water, we can simulate different light conditions and then make the measurements of productivity. Teaching as 2 different classrooms, and it is actually you can bring in participants from remote. they will appear there. It is all it is actually realistic. Yeah, very high tech. This is one of its kind in India.
This is the first time they made it.
Yeah. And if PowerPoints, you can actually project your whiteboard. Somebody can write on the whiteboard, and whiteboard can be pushed to the participants. And then if somebody wants to, project something from a paper, they can actually put it here and you
Control
can
everything
there.
from here.
There's a camera there through which can
When
be
was
projected.
this classroom built?
Last February 2023. After that, several hundreds of students, 20 trainings were done, sir. So because we are a category 2 center under UNESCO, UNESCO has only 2 such category centers for oceanography in the entire world. So we are one such centers. We bring people from Indo-Pacific region to come and train here, both virtually and physically. We train them on ocean observations, ocean data management, modeling, what all activities we do in operational oceanography. We are the center which trains people from the region. IORA and all these agencies also, they actually bring in people. High-tech, sir, India Technical Economic Cooperation, they bring in their trainees here, we train them on oceanography. So all that we do from here. UNESCO Category 2 center. Once in every 6 years we get extended, sir. So by 2024, now we are being assessed again, the capabilities of lecturers and the staff and facilities. It is assessed and then also connect to all that.
Sir, look here.
What is
They will open.
Pull it that.
So, just come little. You can explain.
Sir, actually this signifies, this is sun, this is moon, and then this is ocean. This is a coastal community. It's a beach actually. These are catamarans, and then there is a lighthouse. The concept is that life, actually ocean and life, they are very close to each other. And then it signifies a mother and a baby, newborn, and then young children becoming adults, married, and then the grandfather and grandson. So the entire circle of life has been depicted here. And the life and ocean. So it's a kind of a fisherman community. Those things are depicted. So it's entirely made of stone. Different colors of stone. There is no other thing that is used there. And then sun and moon and the clouds. Synopsis, we are calling it. Synergistic ocean. Sir, 1 second, sir.
गणानान्त्वा गणपतिगुं हवामहे कविं कवीनामुपमश्रवस्तमं ज्येष्ठराजं ब्रह्मणां ब्रह्मणस्पद आनशृण्वन्नोतिभिस्सीदसादनं प्रणो देवी सरस्वती वाजेभिर्वाजिनीवतीं दीनामभित्रियवतु गणेशाय नमः सरस्वत्यै नमः श्रीगुरुभ्यो नमः हरिः ओम्
Sir.
Hello.
కొంచెం బ్యాగ్ వచ్చేసి Come, madam.
We'll go inside. Into the lab. So this is the operation center, sir. I'd like to
మీరు మధ్యలో
Sir, we'll explain actually, sir. Early, what you have seen in the small lab downstairs actually, now we have actually made it thoda side mein. We have made it a very integrated kind of facility, sir. So there is a computing system down below, and the data is processed, and then it comes here. We actually have ocean observations, and we do modeling, we do services. So all that has to be in an integrated way. We need to, somebody has to analyze and then give out all the services that we need. So you can just put the tsunami screen actually. So this is what so this is a tsunami. So what you're seeing in the triangle, all those triangles are seismic stations. We have access to about 400 seismic stations globally. And the data comes in real time. Indian stations, foreign stations, everything comes there. And this actually red line is the current time in GMT. And you see each station data is actually coming in real time. So the data delay is only 20 to 30 seconds actually.
Bombdila data is coming.
We have to check actually.
No, this is your seismic station.
Seismic stations, sir. These are all seismic
Everything
stations.
will be there.
All
Once
data.
data comes, it will be online.
It will be online actually. So once this data comes, then we'll actually make an assess. Automatically it will assess the earthquake. This happened Mindanao, Philippines 3 hours ago. Magnitude is 5.5. And then we detected it in about actually less than 10 minutes. So we can do the detection. Like NCS does land-based earthquakes. We actually monitor everything, but we only act for undersea larger than 6.5 earthquakes.
If it is a larger than 6.5, then there is a likely to tsunami.
Yeah.
But it is first cut. But further they confirm it whether it will come or not with various other
Models, actually.
modeling.
that center part somewhere in Philippines, southern Philippines.
Yes. That is the
earthquake.
earthquake. Current earthquake, sir. 3 hours back an earthquake.
Recent
happened.
earthquake.
Recent earthquake. So this is a seismic subsystem. So first is seismics. Then we actually that is the globe one is the decision support system. So that will actually that is a software that we developed in house. It actually keeps looking where are the seismic events happening. It picks that information and then loads it there, and then it tells that okay, next bulletin has to go if it exceeds a certain threshold. That it does automatically. And then we look at model simulations actually. We also have tide gauges, sir. So if these are the model simulations, sir, for example. Yeah.
That is the water level. The red means more water level. The earthquake, if it is occurred that location, how the water will come. So that is a
Yeah. So sir, that model will tell if the magnitude is earthquake is 8, how much of land will be displaced, how much of water will be displaced. That is actually 2004 tsunami, sir. So which happened in Banda Aceh. How that tsunami wave will travel? Actually, it traveled around the globe.
Which was the epicenter?
Epicenter was off Banda Aceh, Indonesia.
How far from the coast?
It is about 200 kilometers from the coast.
you can show that dot is
Yeah,
there.
that dot is not here, but we can show. Sir, yeah, exactly. No, not there. Bring the hand down. Yeah, that is the epicenter of that earthquake, sir. It is about 200 kilometers from the Indonesian coastline. And actually, tsunami waves came within about 10 minutes. Actually, they reached some of the nearest coastline.
So it hit the Indonesian coast more than any other.
Yes. 200,000 people died in Indonesia.
And also you can see Thailand also.
Thailand, Indonesia, Thailand, Sri Lanka, sir. If you see,
Sri Lanka,
earthquake energy is focused. Red means energy is more, water height is more. Depending upon how the Andaman also, sir. So those are all the near shore. In fact, the earthquake broke from there to the top, sir, near North Andaman. So 1200 kilometer length of earth has broken during that 9.3 event actually. So that is what it caused such a large tsunami. So we do those model simulations, sir. Now those simulations cannot be run in real time. So what we do is we make pre-run simulations of all possible earthquakes. We keep it in the database, and when an earthquake like this happens, we pick our decision support tool picks it from the database and then populates the bulletins. And the other thing is, sir, these sea level sensors. Now, finally, we also have to measure the tsunami physically. Earthquake is only a false proxy. So those measurements, we have 36 tidal gauge stations, sir. You see, each of those triangles is a tidal gauge station. Or anything. So that we do it in real time, and then there are also tsunami buoys in the open ocean, that ITV5, ITV6. So those tsunami buoys also give information in the deep ocean. Those are buoy systems. So using all these systems, tsunami buoy animation, if you have, you can. All these systems, we actually can then give warnings of a tsunami in real time, actually near real time.
If earthquake happens, the bottom sensor.
So if earthquakes, sir, in the open ocean, tsunami height is only about 20 to 30 centimeter. That's all in the open ocean. So it has to detect that 20 to 30 centimeter water level. That is the tsunami traveling. The pressure sensor detects that and transmits to satellite. From the satellite, it comes to INCOIS. So that we can notice the tsunami.
So first acoustically connected, then radio. So inundation map.
Inundation map we have. We'll show actually inundation map also we have. And so we can go to the next one. GNSS.
Sir, this is
We would like you to also.
नहीं कर पाएंगे
Sir, this now seismic stations are there, sir. They can give only a proxy. But then how much earth has actually moved, that if you need to know, you need GPS stations. So those GPS stations, we have installed 35 locations, sir. Each of those guards, these are all GPS stations in the Andaman Nicobar Islands. Each of these is a station like this. This is in water.
They have antenna, so directly it will receive here directly.
It will send the data in real time. So GPS stations, strong motion accelerometers, everything is there, sir. We have 32 stations right now reporting data in real time in Andaman Nicobar Islands. So 3 more will be added.
What was the highest in any state?
Yeah, because there only maximum is happening.
Yeah, earthquakes are happening. So then we'll move to the next one actually. We'll show the ocean state forecasting, other forecasting. So tsunami is one part of it, sir. We also make assessments of ocean state. What will be the wave height, wave direction, swell height, swell direction, all those things, sir. And then, of course, what you're seeing there is actually we have an app called Samudra, on which mobile phone we can actually get this information. So what this is telling is, sir, for example, these are swell waves. They come from southern Antarctica. They come from Antarctica due to winds there. And then they can hit the Indian coast in 4 to 5 days. They travel and hit. So we make those, we have models which can measure those. And then we, like for example, yellow means there is an alert. If you see orange, yellow means watch, orange means alert, red means
Cyclone
warning.
time it will be red.
Cyclone time it will be red, sir. So that we provide, and then we also provide information on currents. We can show currents. So these are ocean currents. This is also done using ocean models. So we make those measurements. And then we have something called search and rescue tool. For example, something is lost in the sea. What is the probability of finding it at a particular place? So we actually work with Navy and Coast Guards so that they can go and find that it could be a ship, boat lost in the sea, fishermen. So that we have. We also have actually information on oil spill advisories. So if there is an oil spilled from a ship or a boat or pipeline rupture, we actually have a system which can analyze where that oil will go. The red is actually where the oil is going from a particular point in the stars. So we can give that information. We give that information to Indian Coast Guard. And then we also provide this information on small vessel advisory, sir. This is an impact-based advisory. For example, the wave height is 3 meters. If it's a large ship, there is no problem. But if it is a small boat, it has a problem. So those areas we identify in that small vessel advisory. And we also provide information on, for Pacific Island countries, we provide information to other countries within the Indian Ocean region as part of our international commitments. And this is Wayne, we want to explain. That is the reanalyzed, which we use as forcing.
This is basically observation plus model, everything put together. What is the best that it has been selected at a different time? Suppose you want 1950 to now, how the ocean is warm, that we can get it from.
Yeah. And then you can show observations. Yeah, these are all the forecasts which we give. As part of the Pacific Island countries, we are actually giving that information. PM has launched actually. And these are all the observing systems, sir. Like you have seen the glider now. This is the location of the glider currently. These are the current locations of the gliders. So 2 in the agencies, 2 in the Bay of Bengal. These 2 are the locations right now. They are going north and they are crossing each other and coming. One is going north, these are the
measurements to be made. The fluorometer allows chlorophyll levels to be estimated. The oxygen sensor determines the concentrations of this molecule in the water column. All the data recorded by the sensors is stored on a hard drive. During the immersion, the navigation data is also registered. In shallow waters, the altimeter is used to avoid collisions with the seabed. When the seabed is detected or the depth objective is reached, the navigation bay gives the command to start the ascent. During the ascent, the glider continues to collect data measurements for temperature, salinity, and chlorophyll. The glider makes ascent and descent.
So that's how it works. So those gliders are there, argo floats are there, wave riders buoys are there. So that is currently how many stations are there in the Indian Ocean region. All the data comes here. So you can click on anything. For example, this is during a cyclone, recent cyclone, December 6th, the Michong cyclone. The significant wave height was very high. So we made a forecast of that 5 days in advance, provided it to all the maritime stakeholders. And this is measured by our buoys actually. So we get all the parameters. This is actually from CODA, coastal.
Another CODA, it will give the coastal currents up to 100 kilometers.
Yeah. So we have 5 sets of those current measuring radars, CODAs. So all that data is actually used here to provide advisories or assimilate into the ocean models or validate the ocean models.
So digital ocean here?
Yeah, digital ocean. Yeah, you can show the digital ocean now. So this is the. So we have these are from the coastal plains. This is from the digital ocean. No.
This is sea bottom. What is the second?
Show that. Here. Yeah. So this is the digital ocean. So all this data which comes in different formats, it has to put in a way that we can analyze it and we can make plots. So that is done through an application called Digital Ocean, which is developed here. So that is the Digital Ocean. You can select all the parameters and then
any year, any depth, any location to ask what is the temperature, salinity, current, everything we should be able to give. It's irrespective of whatever the depth are.
So now we are actually, everybody is talking about digital twin of the ocean or digital earth. So this is actually a thing like a digital twin of the ocean. You can simulate the ocean. And these are other products. We provide products to Navy. For example, Navy wants to know sonic layer depth. Depending on the temperature and salinity, they can know where the submarines, is it safe to hide or where it is not safe. So those information also we provide as atlases to the Navy. So all our data that comes here, sir, it is actually put in the form of these digital ocean applications, several other applications, which can be accessed by users. Then you can show the coastal inundation maps.
So once tsunami occurs, I think how much water will be inundated. That will. This is inundation.
This is the inundation. This is also inundation.
This is all actual readings.
Yeah.
Thanks.
Sir, like you have on Google Earth, sir, but in the rural areas, they don't put building information. So we actually made an assessment of next 100 years, how much will be the water level, sea level rise, and how much of coast it will inundate. Now this is that information. So this is for Tamil Nadu. For example, this much, next 100 years, this much of area will be inundated actually, next 100 years. So that information we have used to collect building information, and then you can zoom that building. One thing.
These are all digitized.
But you can run this video. One thing. Run this video. So it gives the information on that building, sir. For example, who is the owner of this building, whether it's a college or school or what.
This is actual building.
It is actual building on the ground actually. And then we can get information if an inundation happens. It can inundate how many buildings or how many people might be impacted. That information.
This is schools and colleges, people gathering there. So basically, this is one place for observation, data, information, services, everything put together in auto mode. That's the main.
This is one of its kind, sir. Not only in the country but entire.
Just now, actually 100 days before this was eventually.
The computer uses color to distinguish features on the planet. On the land, the color gray and red represent the highest mountains, with yellow and green being the lowest points on the land. In the ocean, the light blue colors represent shallow ocean and continental shelves, while the very dark blue represents deep oceanic trenches, miles below the sea surface. It is well known that the land of the earth contains many mountains and valleys, but what is less well known is that there is a tremendous amount of terrain under the ocean.
You can see
The Mid-Atlantic Ridge is a striking feature that splits the Atlantic Ocean down the middle and is in fact the planet's longest mountain range. Liquid hot magma is constantly being pushed up from the planet's core along the Mid-Atlantic Ridge, creating the mountains and seafloor. This perpetual yet slow process is making the Atlantic Ocean wider at a rate of 2 inches per year, and at the same time pushing the American continents further up.
Bro, encarna, bro. ब्लॉगिंग लो ज़बरदस्त सारा शॉट देखो देखो ऐसा
This is real-time cloud pictures, what you are seeing on the animation.
कैमरा కొంచెం बैक
one how it has been evolved like that. It's a type.
అక్కడి నుంచి
So this is instead of 2D display, it is 3D. You can do anything whatever you want, even ocean currents or
So this is, for example, precipitation, current rainfall in the world globally. What is the rainfall?
now
This is 6th February. It is moving every.
So this is a rain band now. This is a rain band. Right?
If you want to go back to the resets, then it will come back. Yeah, now it is come back to the normal animation. Warmer, 5 degrees warmer than the normal. This is anomaly of the ocean temperature. Different dates. I will show until the current time. This is our own model current from INCOIS. Tsunami, but we can actually get the earlier Indian Ocean tsunami December simulations.
The height is.
Height is in different colors.
You are now looking at a computer-generated picture of the Earth's topography and bathymetry developed by NOAA. Here is our planetary neighbor Mars, as seen by a NASA satellite. Mars rotates on a tilted axis of about 25 degrees, meaning Mars has seasons, just like the Earth. Other similarities include land features such as canyons, mountains, and polar ice caps. If you've been to the Grand Canyon, you know that it is very deep. It is actually more than 1 mile deep and over 200 miles long. On Mars, notice the long gash in its southern hemisphere. That is the...
Show here to be easy to see and visualize. You can make a
The team which developed this system, our industry partners. Please,
Yeah, come.
Very nice. Where is your center?
Bangalore.
Yes, everyone look down. Thank you.
Sir, we'll go there.
కొంచెం వెనక్కుండా ఒక సైడ్కి ఉండిపోండి కొంచెం ముందుకు వెళ్ళండి కొంచెం
Actually, when the operation tsunami are taking it, they can watch it.
We didn't have time to show you this, sir. This is OceanSat antenna. Every 12 noon, we actually receive passes from OceanSat, actually. Those are all the products, sir. And this,
What you want to close it? This room, if you want, you can close it also.
it's digital, actually. You can turn opaque and transparent.
So,
With the click
the
of
outsider also can.
Yeah.
Yes. There is a remote. They are rotating. Just with the button, you can. So that those people need not see us, or if there is a media, we don't want them to see.
So the opaqueness is from both sides.
Yes,
Yes.
yes.
So it's basically when you just click it. Yes. Yeah, second.
It's complete opaque.
Yeah, complete opaque.
Second. It's on both sides, actually.
So that is here.
So the iPad you are
State-of-the-art center to deal with all kind of issues related to ocean. India is a big growing power. We need to understand ocean more. Our activities in the ocean are increasing day by day. So INCOIS is taking all necessary steps. The scientific research and achievements which we have seen over the years which were made possible through the efforts of the INCOIS. We are very proud of this center. I must compliment the director and all the scientists, engineers, all the technicians, everybody associated with the INCOIS. They have put up tremendous efforts in making this center one of the its kind center in the world. We have lots of collaborations with other centers of other countries also. And Hyderabad is a very suitable location for INCOIS. All our fishermen, all the activities, all the stakeholders are getting complementary benefits and supports from INCOIS. I'm very proud that today I could see many new things are also being initiated. The technology being used here, the high-tech classrooms which connect with every part of the world. The students also can come and learn here. Our scientists also impart lots of teachings and other education stuffs being provided here. I can say that in the days to come, this center will become much more a center of attraction for everybody who wants to learn many things about ocean, its life, and especially the conditions in the ocean, the climatic situation, all the hazardous things which we see. Time to time, it is posing as a threat to the people, especially the life in the sea. We have a better understanding about the life inside the sea. The labs here are all of very high quality labs. I could very well understand that coming to this center itself will make you understand the whole ocean life. So Government of India's deep ocean vision and our vision for blue economy will be properly anchored by INCOIS. I'm very glad that today I could visit here and had an interaction with our director and other team members here. Me and Secretary of the Ministry of Arts Sciences, Dr. Ravichandran, he was here for a long time. He served in this center for a long time. And today we came here again. I'm proud of this center.
So 3 sides of India has got the Arabian Sea, Bay of Bengal, Indian Ocean. So 3 different geographical landscapes that India is supported by. How exactly is the state-of-art technology going to help
You see, India has a long coastline. And for any emerging nation, the sea lanes are becoming much more challenging. So to secure our sea lanes, we have to understand the sea, we have to understand the ocean. So in terms of research, in terms of commercial activities, India is an emerging nation. So that is why, as I said, when we talk about our deep ocean mission, means deep ocean exploration, we have to go much deeper, much further. In next 3 to 4 years time, we would be accomplishing our Samudrayan. And for that, all the machineries which you have seen today here, all those gliding machines and all those instruments and equipments which are deployed in the deep ocean, these are going to give us all the feedbacks and necessary informations about the sea. And the humidity, the temperature, the pressure, the wind, the tsunami, all kind of information which are a basic part of the phenomenon which you keep seeing in the deep ocean. These are the things which a country has to deal with. So until unless you have a center like the Indian National Center for Ocean Information here, it will not be able to handle such a vast ocean. So both sides, Arabian Sea and Bay of Bengal and the far deep Indian Ocean. These are vast, expansive territories which the whole global community come over and participate. So we will have to take a lead role because we are centrally located. India has a strategic location which will give us a special advantage. And we have a bounded duty to secure not only our country, but all the peripheral countries like the Indian Ocean Rim. Our tsunami warning system, which is being provided from here, is helping all other the Indian Ocean Rim's nations. So we are one of the main feeder nation which provides basic information to us.
A very good evening to everyone. We are gathered here in honor of a very special guest today. Welcome, sir. It is a privilege for us to have you here. We have with us the Honorable Union Minister of Earth Sciences, Shri Kiren Rijiju. I request your presence at the dais, sir, accompanied by Dr. Ravichandran, Secretary to the Government of India, and Director Engineering Constitution. I request our Director, sir, to please felicitate our guests with a small token of our appreciation. Present a small token of appreciation to Dr. Ravichandran. A few words.
Respected Honorable Minister of Earth Sciences, Shri Kiren Rijiju. Sir, a very warm welcome to INCOIS, sir. I know we all know how busy you are, and then appreciate the time and the effort that you have taken to come down to visit us. Dr. M. Ravichandran, Secretary MOES, my colleagues, media people, colleagues from INCOIS, I'd like to welcome all of you to this to INCOIS on this August occasion. We are very fortunate to have our Honorable Minister of Earth Sciences here. Sir, as you are aware, and then you have just seen the activities of INCOIS. We have been set up in 1999. We have just celebrated our Silver Jubilee 25 years. And then we do a lot of work on the entire end-to-end ocean value chain, starting from ocean observations to ocean modeling to forecasting to services. And then our services go to a lot of stakeholders, include starting right from a simple fisherman to whom we provide potential time on the sea, saving time on the sea, of course, and then spending less diesel, putting less carbon into the environment, catching more fish, so that their economics are improved. So there is a very tangible benefit to it. Of course, you also seen, sir, just now that we provide tsunami early warnings, storm surge early warnings. We actually provide information on climate advisories. So we provide information to navies and coast guards actually on marine search and rescue, on oil spill trajectories. So all this information we provide, and we are one such organization which actually bridges the gap between knowledge generated and then the user needs. So we do that actually, an operational ocean service organization. We have activities in capacity development. We play a large international role, strategic role in the entire region. We work collaboratively with all countries in the region and outside the region to actually enhance ocean observations, modeling and forecasting, and our understanding of the oceans. And sir, your support and the support of the ministry has been tremendous in actually INCOIS reaching this stage, sir. Saying with these few words, I warmly welcome again your good self and Secretary to INCOIS. Thank you.
Thank you so much, sir. I now request Dr. Ravichandran to please say a few words.
Respected Honorable Union Minister of Earth Sciences, Shri Kiren Rijiju, Dr. Kumar, my colleagues and friends from INCOIS. Very good afternoon to all of you. Of course, whatever I want to say to INCOIS, I already said, but I want a little bit brief about INCOIS. Actually, INCOIS is one unique organization. It is having a culture as a teamwork, and they translate science to services for the society. For that, they do from observation, data, information, science, and services. So all spectrum they do. If we talk about the ocean, of course, ocean provides lot in the sense it provides water, it provides energy, it provides what is called, for understanding the climate and other things, it is a main important component. Without ocean you cannot talk about climate. And also it is having mineral resources, both living resources and non-living resources are available. So how much is available, what is the resource potential is there, where it is there, and when it is there, all these things are component of the INCOIS where we try to explore and understand the process so that people can make a technology and dive into the ocean and sustainably harness the resources, either it is energy, or it is water, or it is a mineral resources, or physical resources. All these things, they work together. They are the storehouses of information. So that is why I think in the coming years, maybe in the next 25 years, INCOIS will provide a vital role in terms of blue economy component. I think definitely INCOIS will always contribute significant for the country's GDP in the coming years to come. With this, I close my small brief and maybe thank you.
Thank you so much, sir. I now request Shri Kiren Rijiju sir to please address the gathering.
Dr. M. Ravichandranji, Secretary in the Ministry of Arts Sciences. Dr. P. Srinivas Kumar, Director INCOIS, and all friends who are working here in INCOIS. Actually, after a long time, I could make this visit happen. We tried in the past couple of times, 5 times. We, in fact, given the time, date also. Somehow it didn't happen because of so many other unavoidable things kept coming. But I'm happy that finally we could make it, and I'm very impressed with the campus. The first impression is the campus. What happens inside, you will little later learn about it. But in the middle of the Hyderabad, I've heard about INCOIS, in fact, not only from our secretary and other officers, but from other people also. Recently, the Vice Chairman of the NITI Aayog told me that he was unaware of such a fine center we have in India. He was so impressed. He told me that he would like to collaborate with for many other future planning for India's growth story. And you are, I hope you are not feeling bored here in this beautiful city. Today I went to ISRO Center in Sriharipatna. The scientists told me that they are isolated. They don't have life. The location is such that it's far away from the city, and the young, especially the young scientists, they don't want to stay there. The main problem is the location. But here you are right in the middle of Hyderabad, so the issue is not there with you. But having said that, the purpose with which this center was established, I think you have served it very well. In fact, you have gone much ahead of what was planned initially. Because all these subjects, the activities which you are carrying forward are of immense importance for the country and beyond. You are serving the global community, and slowly this will become one of the major centers. And the effort which you have put in today, what I have seen in little available time which I had, I'm very impressed. And especially our director, he is all the time on a driving mode. try to do something new or get some fresh things into the center. One of the greatest advantages is the secretary is also one of your center. You stayed here for 16 years. So 16 years is not a small span of time. So our secretary sir has an emotional bonding with you as well as experiences of his serving days here. We are fortunate that we have a scientist secretary. Normally, secretary to the Government of India are extremely busy with their administrative work. So it is a well thought of that some of the departments, some of the ministries will be headed by the domain experts. So Earth Science Ministry is one of those ministries which is a very specialized job. So the secretary is very appropriately being handled by Dr. Ravichandran ji. Because for me, I am a novice. For me, science is an area which I look from far away till I became the Minister of Earth Sciences. Some of you may be aware of my responsibilities in the past. I had worked in various capacities. During Vajpayee's time, I was in the small scale industries as a member in the commission which used to look after industries, small scale industries, khadi. Then I served as member of parliament, so I used to travel a lot. But as a minister, I served as Minister of State in the Home Affairs. I served as a Minister for Youth Affairs and Sports. I also handled the Ministry of Ayush, Ministry of Minority Affairs. So I have been telling Dr. Ravichandran that I have handled with so many people in the sports fraternity, the lawyers, judges when I was law minister. Then I handled the security of this country as a minister in the Home Ministry. But when I came to the Science Ministry, my dealing with the scientists is most interesting. Maybe I'm a little selfish because the scientists never give you trouble. Scientists are busy in their work. All the scientists are extremely occupied in their respective field. So they are not a trouble for anybody. They are biggest assets of the country. So the scientific community are the pillar of India's growth story. When we talk about India becoming a fully developed country by 2047, that means we have only 24 years and a half left. In past 75 years, we have developed quite a long, but we could not become a fully developed nation. But in the next 25 years, we have to become a developed nation. That is the target set by the Honorable Prime Minister. So there the scientific community will play a very critical role. A nation who leads with science will be a global leader. That is why the new slogan had to be added. So in 1965, when Jai Jawan, Jai Kisan slogan was given by Lal Bahadur Shastri, then Prime Minister, that time it was thought that the farmers, for the sufficiency of food, and the Jawans to secure and protect our country. Then you know very well when Vajpayee in 1998 added Jai Vigyan. Now after science, Prime Minister Modi ji has given a new dimension that science without research is not complete. So Jai Jawan, Jai Kisan, Jai Vigyan, Jai Anusandhan. So that is how the role of the scientific community becomes critical. So our government has put the scientific community right in the front of our quest to become a prosperous nation. India has to lead the world. I think it is our destiny. We are destined to lead. Otherwise, in the 19th century, Swami Vivekananda had stated I think many of you know, he predicted 200 years back that India will lead after 200 years. Means 21st century will belong to India and Indian people. And that is what we are seeing today. It's happening. In last 10 years, the kind of growth you have seen in India's economy and in various sectors. And today, as Prime Minister is in UAE addressing the global community, the whole world is watching what our Prime Minister is saying and what our country is doing. So that is why silently, from the behind the scene, you all are actually fulfilling the vision of 1.4 billion Indians. We are very proud of you all, and about the ocean, about the need, about what to do, it's there, you all very well know it. I don't need to take any extra time talking about the subject matter which you are already dealing with. But what impressed me most is that whatever you are doing is directly benefiting the common people. That is what we call from lab to land, from science to services. So it's directly connected with the people. That is why I kept telling our officers in the ministry that it is our duty in the ministry to ensure that whatever our centers are doing must be brought closer to the people. Let people know these services are because of you all. So that is why you work so silently. Many people do not understand the efforts behind your hard work, the amount of efforts you put into your paperwork, your research, your understanding. It's tremendous. So that is what we need to, bridge between the common people of the country and what our scientific community are doing. I'm very proud of you all. As I said, I have nothing much to say except to appreciate what you are already doing. Anything extra support in terms of policy support, financial support, technical support is required from the ministry, you don't need to worry. I assure you, all necessary support will be provided to your effort and to make sure that INCOIS becomes much more than what you are already. So we will ensure that INCOIS will be a place to visit. Thank you, Sri, for arranging everything so in a short notice, because I was not very sure, but Secretary and we planned on just a few days back that we must come this time. If we miss this time, it will be terrible for me. So we managed to come here, and glad to meet with you. And some of you have seen your work already, how you have done. And for your family, for your support, for your all other things which make you comfortable for you to work here, I will always pray for you and your family so that you work with full happiness. You must be happy. That is all. Thank you very much.
Thank you so much, sir, for your kind words. Thank you so much for appreciating the work that the entire INCOIS family has put before you arrived, and we will continue to do so in the future as well. Thank you so much for taking the time out to be with us here today. I request our director, sir, to please felicitate our guests with a small token of our appreciation. Rijiju, sir, please felicitate our guest with another token of our appreciation. I request our director, sir, to please felicitate Dr. Ravi Chandran with a small token of our appreciation. Oh, I'm so sorry. I now request the winners for the sports sports competitions to please come on stage and line up behind the institutes participated. The competitions were held for over 2 or 3 months in honor of the 25 years of excellence that INCOIS has been able to achieve. Thank you so very much.
Good evening to you all. It is with immense pleasure and gratitude that I stand before you to extend a heartfelt vote of thanks on behalf of INCOIS colleagues on this memorable occasion. Firstly, we express our profound gratitude to the Honorable Union Minister of Health Sciences, Shri Kiren Rijiju, for taking time to visit INCOIS, inaugurating the state-of-the-art operational service facility SYNOPS, SMA and GNSS network in Andaman and Nicobar Islands, and unveiling the mural on life and ocean. Sir, we are truly honored to have you with us today, and your presence has added immense value to this event. We are grateful for your support and commitment to enhancing the activities of our institution. Sir, your insightful suggestions and advice have been duly acknowledged, and we assure you that we will further strengthen our services for the benefit of all the blue economy stakeholders. We extend our sincere thanks to Secretary MOS, Dr. Ravichandran, for gracing this occasion with his esteemed presence. Sir, your encouragement and guidance are instrumental in propelling the initiatives of our institutions forward. I also thank colleagues of Ministry of Health Sciences for their unstinted support to INCOIS. A special note of thanks is also extended to our Director, Dr. Srinivas Kumar, for his leadership and vision in steering our institution towards excellence. Thanks for your support in meticulous planning and your attention to every detail that ensured the realization of the SYNOPS facility in a record time of 65 days. We are confident that this new facility will play a pivotal role in cultivating an environment of learning and innovation. Moreover, it is poised to enhance our collaborative efforts with global institutions, further expanding our services to the global ocean and emerge as a global leader in operational oceanography. Setting up of such state-of-the-art facility will not happen overnight. Behind the scenes, countless hours of dedication and coordination have ensured the successful completion of this facility in time. My special thanks to Mr. Annapurnaya, Mr. Murali for their commitment and dedication in setting up of this facility. I also thank each one who worked tirelessly behind the scenes. Additionally, I take this moment to express my sincere thanks to Sigma AVIT and their partners for excellent planning, management and establishment of this SYNOPS facility within challenging time frame. Lastly, but not certainly least, congratulations to all the winners of sport competition and the sports committee. I thank the group directors, divisional heads and colleagues from Executive Support Services for their support in successfully organizing today's event. We are also thankful to both print and media for covering today's event. Once again, I thank you all for being a part of this memorable occasion. Thank you.
Thank you so much, sir. I thank everyone who has gathered here with us today. I now request the dignitaries to please proceed towards high tea. I request the audience members to please wait till the dignitaries leave. And then
लोग यहाँ आते हैं और यहाँ से आदान प्रदान करते हैं। बहुत हाईटेक सेंटर है। आज मैं इस सेंटर में मेरे मंत्रालय का ये बहुत बड़ा सेंटर होते हुए भी मैं कई सेंटर विजिट किया, तो ये विजिट नहीं कर पाया। इसका कार्यक्रम में तो मैंने अटेंड किया, लेकिन आज मुझे यहाँ आने का मौका मिला। मुझे बहुत अच्छा लगा। यहाँ डायरेक्टर और बाकी सीनियर ऑफिसर और वैज्ञानिकों को मिलने का मौका मिला, तो मुझे अच्छा लगा। सबसे हमने चर्चा भी की है।
तो इंडिया का डीप वाटर मिशन है, तो इसके बारे में बताइए, स्टेट ऑफ आर्ट टेक्नोलॉजी कैसे यूज़ होगी?
देखिए, यहाँ जो भी मशीन, हमारा जो ग्लाइडर मशीन है, बोरिंग्स है, या कोई जो साफ लगाने के लिए रस्सी लगा करके हम लोग समुद्र में कई चीज़ें भेजते हैं। कई मशीन ऐसे हैं कि हम 1000 किलोमीटर से आगे भी भेज देते हैं। सारा जो बहुत डीप ओशन का वो चल रहा है। साथ साथ हमारा समुद्रयान, आपने चंद्रयान तो सुन लिया, देख भी लिया, गगनयान का तैयारी चल रहा है। साथ साथ समुद्रयान भी बहुत तेज़ी से कार्यक्रम आगे बढ़ रहा है। हमारा डीप ओशन मिशन के तहत समुद्रयान जो है चेन्नई में नेशनल इंस्टीट्यूट ऑफ ओशन टेक्नोलॉजी का सेंटर में हमारा सबमर्सिबल मशीन बन रही है। मैंने जाके टेस्ट करके देखा भी है। 2-3 महीने के बाद एक टेस्ट भी हो जाएगा इसका। वो लगभग 6-7 हज़ार मीटर तक अंदर सागर के अंदर जाएगा। उसके बाद ब्लू इकोनॉमी को लेकर के कई प्रोग्राम चल रहे हैं। ये INCOIS के माध्यम से कार्यक्रम हम लोग कर रहे हैं। तो डीप ओशन मिशन में गहरा सागर के अंदर में खनिज होते हैं, बहुत चीज़ें होती हैं, वो हमारे इकोनॉमी के लिए बहुत बड़ा काम आएगा भविष्य में। उसको हम एक सस्टेनेबल तरीके से कैसे इस्तेमाल करें, वो इकोसिस्टम जो है उसको बर्बाद नहीं करना। हम बहुत एक जिम्मेदार देश है, इसलिए सागर के अंदर से जो भी हम आपदा संपत्ति जो निकलेगा उसको हम तरीके से करना होगा। उसको अंधाधुंध आँख बंद करके संपत्ति को एक्सप्लॉइट नहीं करना, उसको तरीके से करना। उनको कहाँ जाना है, कौन सा मछली कहाँ मिलेगा, कितना गहरा मिलेगा, तो सारा इन्फॉर्मेशन हमारे और टेम्परेचर, प्रेशर, सारा इन्फॉर्मेशन आजकल फिशिंग जो है बहुत थैंक यू जल्दी निकल जल्दी।
गाड़ी आपकी ये नहीं ना, ये हमारी गाड़ी पीछे पीछे बोली चल